It is, I'm here to introduce my friend Jeff Millman. Jeff and his family live in the village of Ayr in southern Ontario, about an hour west of Toronto. Jeff is a longtime O-scale narrow gauge and standard gauge modeler. His 1953 era Western Maryland Model Railroad set in West Virginia, complete with a narrow gauge logging line, is substantially complete. And he embarked on an additional ON3 layout about 4 years ago. The theme of that new ON3 layout is the western slope of Cumbres Pass from Chama to Cumbres, with ample staging at each end, and it focuses on train and helper movements over the line. Benchwork and track are complete, and scenery is at the early stages. The layout is dead rail or power on board if you prefer. Jeff is a member of the Maple Leaf Modelers and very much enjoys being part of a group of like-minded narrow gaugers. So Jeff, it's over to you.
Thank you, Jerry. I'll go ahead and share my screen. Share. Everybody can see that. Can you hear me? Can you hear me okay?
Perfect. You're doing good.
Okay, thank you. Yeah, thanks for the opportunity to present. Title of my presentation tonight is Interested in Building in Brass, Yet Reluctant. Me too. So this is a tale of a skilled modeler with not much experience in brass, and this is my journey. Jerry's already introduced me. Just the image there, I just need to move things around on my screen a little bit, shows an early brass construction that I built when I was 17 years old. It's a freelance center cab diesel. It was an interesting build, but my go-to scratch building material for more than 35 years has been styrene. It still is, although modeling Colorado narrow gauge has brought me back to brass for obvious reasons. So I want to talk about an approach, how I approached getting into doing some brass modeling. I started off by finding myself some experienced and generous mentors. I'll just give a bit of a shout out to them. Stan Parsons, Al Collins, Keith Stamper, Jerry Cornwell, many of those folks. And I worked on something that was comparatively easier first, rebuilding a couple of basket cases, reasoning that I couldn't make them worse. Took things at my own pace, became comfortable with my own techniques. And bottom line, you kind of apply the wisdom of Irma Bombeck, that being housework done properly can kill you. Some of those details are just going to be in the shadows after all. So here's an outline for what I want to talk about tonight. Safety first, very brief discussion of tools. Full disclosure, I'm a resistance soldering guy, so that's what I'm going to be talking about. We'll go through some very basics of resistance soldering, rebuild of a couple of basket cases, just some mock-up examples, and then applying those techniques to one of those brass beauties, getting it out of the orange box, and then finally just some thoughts on tackling a kit. I put that in quotation marks. So safety first, obvious stuff, eye protection, a dust mask when you're doing dusty stuff. A little pot of water on your desk is handy for hot parts and hot fingers. And you really just should have a fire extinguisher at hand. So I've got lists of tools. I won't go through them in any detail. These are kind of the tools I want to emphasize, but I'll go to the pictures first. First and foremost is a comfortable, well-lit workspace. That's my workspace. I work in a standing position because that's most comfortable for me. Spend the money on a really good set of files and only use them on brass. You can have other files for filing other stuff. I have sewing machine foot pedal controls for my Dremels. It frees up an extra hand. Your third hand clamp is something you'll use lots of. And then finally, flux and solder. I keep it simple. That's 60-40 rosin core, 3/4 millimeter solder, and OD number 5 flux. I use that for for everything. So resistance soldering, this is a typical resistance soldering unit. In essence, it's a targeted shorting out process. You're creating a short circuit that concentrates the heat in a very local area. So you've got the unit with the transformer, there's the prod and grounding clip method, there's tweezers, different method for using the tool, and a foot pedal for on and off. So I thought I would do a very basic overview of resistance soldering. Our project for tonight is on the left. It's a flat piece of brass soldered to an angle. So need to clean the parts. You can use a wire wheel in your Dremel, or you can use fine emery cloth or steel wool, whatever, but just bright metal finish. I tin one of the parts, put a generous amount of flux on. Now in the middle, I'll show the tweezer method. You can see the tweezers going in and pinching the setup. Once it's got good electrical contact, activate the foot pedal. You'll get lots of smoke and the solder will melt, and within a few seconds, you've got a completed solder joint. On the right-hand side is the prod method. You need to electrically attach the grounding clip to the part, apply the prod to the part, activate the foot pedal, same thing. It'll heat up really fast, turn all the flux into smoke, melt the solder, and you'll have a really good solder joint. So just to point out, there is an arcing hazard with resistance soldering. You shouldn't activate the foot pedal before contacting the workpiece with the prod or the tweezers, nor should you remove the prod or the tweezers from the workpiece with the foot pedal activated. So just a few notes here. Oops, I'm sorry, a few notes. We talked about the arcing hazard on the previous slide. You'll probably use the prod about 80% of the time. The prod is slowly consumable and need to be resharpened as you go. You can use your Dremel or a pencil sharpener, whatever works best for you. Electrical connectivity is essential. The parts need to be cleaned for soldering, but they also need to be clean or clean enough to make electrical connection for the resistance soldering tools. I use lots and lots of flux. You don't want to get partway through and boil all the flux off and it reoxidizes. So that's why I use lots of flux. There's a bit of a trick to setting the power level on the resistance soldering unit. You kind of need to get the feel for it. It's very possible to vaporize small castings and wire bits. Just kind of a naive little illustration below in the pre-poof configuration, and then with the power level a little bit too high, vaporize that piece of wire there. So it takes some practice to get the power level right for the different application. A few other thoughts, and you can see the illustration on the upper left. It's a bit globby, our wire soldered to a piece of flat brass. Not to worry, that's pretty easy to clean up with an X-Acto blade, a flat X-Acto blade. Another handy tool is the wire wheel for pre-cleaning and buffing after soldering in your Dremel. Always wear eye protection with one of those things. Coarse cutoff wheels and fine cutoff wheels come in handy doing brass work. So let's go through a few projects. I picked up a couple of old Max Gray K28s, one in vintage condition and then one that was partially upgraded. I'll touch very briefly on precision scale K37, getting it out of the box and operating as a finished model, and some progress on a K27 kit that I'm working on. But first and foremost, the first step is to do your research, purchase all the parts and components and supplies that you'll need to support the progress with the model. I just want to give a brief shout out to Precision Scale. They've been awesome at supplying all the necessary detail bits. really very responsive. So here's one of the Max Gray models. You can pick these things up at shows. There's lots of them around. It's a nicely proportioned model, very rugged. In this case, the mechanism ran well, so it was a good candidate for upgrading. It's very sturdy, almost brick-like model and well proportioned. This was the other K28 that I had. It was partially constructed. Just want to do a little bit of a shout out on the cab interior that came with this model constructed by the late Harold Midwood. It was just a beautiful little piece of craftsmanship and part of the reason for wanting to restore the model or finish it off. So as you're approaching these things, it's always a good idea to start with something comparatively easy and build your techniques. And I found building the tender was a good way to start that. It's sort of the stepsister of the combination, and people aren't going to look at it that closely, so you can hone your techniques on the tender. I found redoing the cold door area to be one of the most challenging areas. You've got multiple pieces to add on, and you don't, trying not to unsolder things while you're soldering new things on. So that was a good way to hone techniques. So I just want to go through some simple mock-up examples. The prerequisites are that the castings that we're going to apply are pre-tinned. All of the surfaces are clean, lots of flux applied with more at the ready if you need it. And with a bit of practice, smaller parts can actually be held in place with the tweezers or the prod if more flux or solder needs to be applied or the power needs to be adjusted during the soldering process. So you get a kind of a technique for that. So in our upper left-hand corner, we're using the prod to apply a water hatch to a tender. In the middle, at the bottom, we're using the prod to apply a step casting. Over on the right-hand side, holding a truck chain bracket on a tender frame with tweezers. And then over on the left-hand side, installing a ladder with the prod. That one's a little bit dicey. That ladder casting is very delicate. There's a pretty fine margin between soldering the ladder on and vaporizing it. If you can get the prod on the inside of the tender, it's a little bit better. But the techniques are all the same as our simple example. Apply the prod or the tweezers, activate the foot control, you get lots of smoke, it melts the solder, take your foot off the foot control, and with a bit of practice, you'll have a good solder joint. Works really well. Just some other ideas. Cutting sheet, you'll cut lots and lots of sheet. In our example, we just have a little sheet with a scribe line. We've got to cut that off for a part. I clamp it between two wooden blocks with a heavy C-clamp and use one of two methods to cut it out. On the lower left, option 1 is with a razor saw. On the upper figures, option 2 is to cut it off wide of the mark with a heavy cutoff wheel and then sneak up on the line with a fine cutoff wheel, and in both cases finish it off on a flat file. So simple illustrations, but you develop a technique. So back to our model, this was the vintage Max Gray model. The first step is to deconstruct it. Largely I did that with the prod, although the domes came off with a plumbing torch, and the cab can be pried off with a prod and a straight X-Acto blade. So that's kind of the deconstruction phase. You'll get lots of globs of solder all over the place. Running the prod over that will burn off a good amount of that solder. And follow that up with air erasing to clean up all the stray solder. Here we see the model kind of coming back together. The domes have been upgraded and installed back on. Because they're fairly large, I actually used a little micro torch that I got at Home Depot to put those back on. They go on in a flash, as well as the stack. You can see the cylinder saddle assembly has been upgraded. There's a new smoke box front, which is a precision scale casting, not quite the right diameter. So I made it larger in diameter by wrapping it with a piece of sheet and then just carefully grinding and filing it back. So a little bit of handwork in some cases. A distinctive feature of the K28 are the rounded front cab corners. Of course, the model has square corners. So I used a very fine cutoff wheel in my Dremel and just kind of snuck up on the right shape and soldered a round piece of brass wire for the rounded corners. I was happy with the results. And typically I'll solder nuts on for cab hold downs or tender body hold downs as well. Sorry. Now, this is just an overall shot of the build progressing. I won't go through this in excruciating detail other than to say, kind of plan your build. It's logical, start from the inside out and the bottom up so you don't construct yourself into a corner. You get into some areas like the turret, for example, where there's a lot of little bits and a lot of little solder joints coming together. I just use little pieces of wet Kleenex tissue to protect solder joints that I don't want to unsolder. The advantage of resistance soldering is it's very local and very quick, so you can manage the heat. Another little mock-up installation, a mock-up simulation of a bell installation on the upper left-hand corner. And then a nice little detail on the lower left-hand corner, these boiler band clamps. Those castings come with two little prongs. I suppose you're supposed to drill a couple of holes for those to go in. I just grind those off, fit the clamp on the boiler, hold it with the prod, and zap them in place. Once they've been pre-tinned, of course. This is just a note to say there isn't a detail part for everything. The hinge blocks and the tender grate hook are just pieces of brass material, largely that I use a fine cutoff wheel and kind of sneak your way up to the final shape. And maybe you need to make 5 parts to get 3 good ones or 2 good ones, but it doesn't take very long. And then the blower connection is kind of a composite of a square flange and a pipe T and other pipe components to simulate that detail. Having gotten the above the running board details done, then you can go in and do the below running board details. That's going to make the model a lot more delicate and difficult to handle, but that's the stage we're at. It's always nice to include an open cab door if you can. The Max Gray model was good in that it had a separate piece for the cab door, so it was fairly easy to open it up. And then on the other side, and just a detail, the injector, sharp eye will notice the injector is soldered on backwards, but that's where you apply the wisdom of Erma Bombeck. Nobody knows that except you guys, so it's good. And then the cab interior, I worked with a precision scale cab interior detail kit. Same process, start from the bottom, work your way up, start from the stuff that's close to the back head and work your way out, and don't kill yourself. The detail is incomplete on the top of the back head, but you can't see it after the cab's on, so it doesn't really matter. Another nice little detail is a cab apron to the tender. That's often missing on models, and it's just a nice finishing detail. And then the water valves inside of the valve cabinets on the tender. It's kind of a nice detail. You really can't see them when the model's done, but they're there. And then to the drive mechanism. As I said, these models had good drive mechanisms. They ran well. I replaced the motor. You can see the new motor mount, a little bit of work on the gearbox spring arm, and a little shim in the gearbox to minimize back and forth play, and it's quite a good runner. So there's 478 in the completed condition, and there's 476 prior to painting, and there's the model painted. So I'm just going to back up one slide. You can see the odd little smear of solder, but you know, it's all flush and scraped back to the brass surface. You can't see any of that once you paint it. So don't knock yourself out on getting rid of all traces of solder. Make sure you have good solder joints. So still some work to do on this model. Headlight, marker light, lenses, number boards, crew, weathering, but it's coming along. So just some other ideas to think about. The craft aisle at Michael's is a pretty handy place to find chain. Even found half round beading that was the right size for the beaded edge around the top of the tender. It was almost perfect size. And then of course, if you're missing rivets anywhere, those lovely little Archer rivets can be applied after priming and before the top coat. So you can do things that way as well. So just a couple of more examples. This is an example of getting one of those brass beauties out of the orange box. This is a precision scale K37 that I acquired. Lovely model, it ran well, but it was missing a whole bunch of bits. It needed some modifications and some repairs and some significant backdating in a few places. The model represents the K37 as it existed in the late 1950s, and I model earlier than that. So using the skills I developed on the K28s, I had the confidence to kind of tackle the upgrade of this model and turn it into that. I was happy with the finished product. So then my current project is to tackle a quote unquote kit. This is a K27 that I acquired from somebody who had done a significant amount of work on it already, really high quality work. Nonetheless, all of the stuff in the yellow circle were the missing bits. That's the stuff that didn't come in the kit. My experience with kits is they usually come with all the parts and instructions, but not this one. The tender is progressing well in the green square, but that's my current challenge. Fortunately, I'm part of a group of 6 people that are working on these kits, and there's a mix of experience level and some pretty experienced modelers in this group. So I'm learning a lot from this build. Here's some early days images from the tender construction, tender underframe and side frame. One of the trickier bits is soldering those tiny little NBWs on the end beam. You can see the inset photo on the lower right-hand corner where you're sneaking up on that NBW with the resistance prod to heat up the area around it and melt the solder in behind. You have to have a steady hand at that, because if you touch the NBW, there'll be no more NBW. But again, that's just practice. So that's kind of quick, but I'm about at my last slide. I just want to say some notes about painting. It's not really certain which causes more anxiety, either building brass models or painting them, but that'll be kind of a subject of a combined presentation between Al Collins and myself next month about painting. So that's it. Hopefully I didn't lose too many people.
I think they're all still awake. Jeff, thank you.
Excellent.
There were a couple of questions in the chat box. Most of them we covered off from the chat. There was a couple of people asking why you didn't have your video on. That's an interesting question. What happens there is that we've discovered that if you have the video off and you're presenting, it means we have less or fewer problems or less likelihood of problems with the slides, with the PowerPoint slides, some kind of Zoom issue. The item that the photographs were taken on the little project that he was showing, that Jeff was showing, that was a ceramic soldering pad. Do you want to comment on that, Jeff, how you use that?
Oh yeah, the little rectangular object with all the holes in it.
Yeah.
Yeah, that's from um, so they're usually a ceiling mounted uh, a high intensity natural gas area heating unit. They're just little replacement squares. So I have a friend who's in the HVAC business, and those are ideal little squares for doing any high temperature soldering work on. So if you have a friend in the HVAC business, yeah.
Yeah, they're ceramic, and they're also available from jewelry suppliers. And the little holes that are in them, a standard 1 inch or 3/4 inch brad will fit in those holes, so you can use them to hold things in place.
Yeah,
it's quite handy.
It's a great little thing. Yeah.
Dan was asking what the prod tips are made of, and between Dave Adams and I, we answered that, indicating that they are copper clad carbon.
Right.
Mark Lachey says, very nice presentation, impressive work. Barry says, great presentation. Brian says, that's fantastic. Inspirational, very informative. Yeah, thank you, Phil, on that comment. What sort of iron do you use to tin the parts?
I use an old Weller soldering gun. It's one of those 2-click ones, 100 watts, 150 watts. And I can tin everything with that. I actually don't own a big soldering iron. I have a small soldering iron I use for electronics work, but that's all I have.
Yeah, I'm in the same boat. Yeah, I find the old style, not the newer ones, but if you can pick up one of the older Weller irons, I believe they're 300 watt, and their trigger has got 2 steps, so there's a medium heat and a lower and a higher heat.
Yeah,
and they're fantastic for tinning brass parts. Good, very, very quick.
Yeah,
and easier to do. Oh, here's a good question. Can you use too much flux?
I suppose you can, and the flux gets all over the model, and the whole model is just kind of a gooey mess. And if you leave it long enough, it starts oxidizing. That's where having an ultrasonic cleaner comes in handy. If the model starts getting too gooey, just a quick 5-minute run through the ultrasonic cleaner will clean it all up again. So I suppose in theory you can, but I glob it on pretty good.
Sid is asking if the scale of the example locomotives is 0 and 3, and the answer to that is yes. Phil's asking, how do you clean up the flux? But I think we just answered that. Barry is asking, what material do you use in your ultrasonic cleaner?
Okay. I use softened water, and for cleaning the flux off, Dove dishwashing detergent. And then for getting ready to paint and deoxidize, I'll use a brass cleaner that you dilute, and then a final clean prior to paint. I'll either use an acid etch or give it a once over with an air eraser to clean it up for paint. Give it a bit of a toothy finish for the paint to stick to. But we'll cover that in more detail next month.
Yeah, we're gonna cover that next month for sure. Yeah, was it Dove or Dawn dishwasher stuff?
Thank you, Dawn.
Yeah, I thought so. Yeah,
thanks, Jerry. You can tell how
I don't know if it makes any difference. But
well, you can tell how often I do the dishes.
It's interesting if you do a search online about cleaning brass parts or cleaning things prior to painting. Almost everybody recommends using Dawn and the ultrasonic cleaners. I'm not really sure why. So I think that maybe have wrapped up. Chuck and Scott Proudfoot is saying we use a foam carbon block for smaller parts and need to be held with pins. You can get them from China. Oh, foam. Okay, a foam carbon block when you're holding things down for soldering them. Okay.
Cool.
Probably from Amazon, right?
Yeah, cool.
So that's the thing about these things. You always learn something.
Yeah, that's cool.
Okay, thanks, Jeff.